Alright guys, today we're going to look at using the product rule to take a derivative. You'll use this anytime that you have a function that is the product of two functions themselves. So you're going to take the derivative of the first function times the second function plus the first function times the derivative of the second. And so it's very important that you're able to identify what your two functions are. So in this case, you have f of x and g of x. We'll just generally note them. And so we want to take the derivative of the first times the second plus the first times the derivative of the second. Alright, so we're also going to have to use the power rule when doing this. So on our first derivative, we're going to have 3x squared, 3 multiplies to the front, times the derivative, or times the second, not the derivative of the second, so negative 5x to the fourth plus 2 plus the first, and so that's just our x cubed times the derivative of the second, and so we're going to get negative 20x to the third. The 2 is a constant, so its derivative is 0, so we're just going to get the negative 20x cubed. Our next step is to simplify, and so we just use distributive property. You do need to remember that when you're multiplying like bases, so in this case x and x, you add their exponents when you're multiplying. So that gives us x to the sixth, and then don't forget to distribute to the 2 at the back, so plus 6x squared plus multiplying here, we get negative 20x to the sixth. Combining like terms with our largest exponents going first, and we get negative 35x to the sixth plus 6x squared, and that is our y prime, so our derivative. Alright, so let's look at our next one. Let's go ahead and identify our two functions, f of x and g of x. And so we want to take the derivative of the first times the second plus the first times the derivative of the second. And so we're going to get negative 10x because the 2 multiplies to the negative 5, and then the 2 becomes a 1. We don't have to write that. The 5 is a constant, so it's just going to become 0 times the second plus the first, so our negative 5x squared plus 5 times the derivative of the second, and we just get 8x to the third. So the 4 drops down 1 to 3. And then again, so distributive property to simplify, and so that's going to give us negative 20x to the fifth. Remember, there's a 1 on our x here, and so when we multiply x times x to the fourth, we get x to the fifth. Don't forget to distribute to the 3, and it's not going to be plus, it's going to be a negative 10x, sorry, negative 30x, minus, and I know we have plus, but this here is going to be negative since it's a negative 5x squared, so you can go ahead and write minus negative 40x to the fifth, and then you have positive 5 times 8, so plus 40x cubed. And so when we combine like terms, we get negative 60x to the fifth plus 40x cubed minus 30x. And that is our y prime, our derivative. Okay, so let's look at our next example. Alright, so identify your functions. We have f of x and we have g of x. Again, power rule. Now I do want to mention, I did notice this on some of your all's power rules. We have to treat negative 3 differently than a positive where it would become smaller. It's still becoming smaller, but when you take 1 away from negative 3, it's not negative 2, it's a negative 4. So this is going to give us a positive 6x to the negative 4. That's our derivative of the first times the second. So just 4x to the fifth plus 1 plus the first, so negative 2x to the negative 3 times the derivative of the second, 20x to the fourth. The 1 just becomes a 0. Now we need to simplify again, so just go ahead and use distributive property. I do want to note that in other problems, when we've multiplied like bases, we're adding their exponents. So here we have a negative 4 and a 5. So when we add these together, we're going to get a positive 1. So the 6 times 4 is 24, but your negative 4 and 5 become a positive 1. And then you distribute to the 1, you just get 6x to the negative 4 minus, go ahead and say minus just because you have negative 2 times 20, which is negative 40. And again, if you didn't understand, or if you need me to repeat from the last example, when you're multiplying like bases, you add the exponents. Well, negative 3 and 4 is 1, so we just get x. So when combined like terms, we're going to get negative 16x when you combine these. And because we don't want any negative exponents, we're going to write this as 6 over x to the fourth. So just like we did in the power rule videos and assignments. Okay? All right. Next example and last example. Again, we want to note what our functions are. So we have f of x and we have g of x. Now, in this, I would first do a rewrite. I think that's important to rewrite your problem. And so this is going to be 2 minus x to the fifth to the negative 4. So you want to put this in a position to do the power rule before you actually do the problem. And so, like I said, this step right here, this whole step is just a rewrite before we actually do the problem. Okay, so into doing the problem, again, you have your f of x, and you have, so denote them again, f of x, and you have your g of x. And we're going to want to take the derivative of the first. And so the derivative of 2 is 0. When you take your negative 4 times your negative 5, you're going to get positive 20x to the negative 5. Remember, when you take a 1 away from a negative, it makes it look like a bigger number, but it's actually smaller. So we get a negative 5 times the first, or times the second, so times our g of x, 5x squared minus 1, plus the first, 2 minus 5x to the negative 4, times the derivative of the second. And so that's going to give us 10x, and the negative 1 just becomes 0, so we don't have to write anything. And then we're going to do our distributive property. And again, the same thing goes. We need to multiply our front numbers, so that gives us 100. And then, like bases, add exponents, so x to the negative 3 times the negative 1 gives us negative 20x to the negative 5 plus 20x. We're going to distribute here. And then on our last distribution, we're going to get negative 50x to the negative 3. So the 1 on the x takes 1 away, or adds 1 technically to the negative 4, making it negative 3. All right, so combine like terms, if there's any like terms to be combined. So here, those both have an exponent of negative 3. So we can write that as 50x to the negative 3. And then we'd have minus 20x to the negative 5 plus 20x. And so now we just need to write without any negative exponents. And I would actually put the 20x in the beginning, because it's to the 1, which is a bigger number than your negative 3 or negative 5. So your y prime would be 20x plus 50 over x to the third minus 20 over x to the fifth. Okay, and I know you guys will need some more practice. This is probably the steepest thing we've done. We're also going to have a video next on the quotient rule. But down here, I have some problems for you to look at to try on your own. And so I'll just give you a second to look at these problems. Again, you can hit pause anytime that you need to hit pause. All right. This actually would be a good time to hit pause because I'm about to present the answers. So here's the answers to the first two. The next 3 and 4. And then here's the answer to the last one. All right, guys. Hope this video helped and finds you well. Have a good day.